Okay. First, welcome everybody to attend our AP Phase 1 class. And make sure before the class, get my syllabus ready. Okay. I will put the syllabus into the Google Drive later. So make sure before each class, get the syllabus ready. Then that is easy for you to follow. In the end of the syllabus, I list the reference book. That is a policeman review book. Okay, any kind of word is okay because no difference for our purpose. Why we like to choose policeman review book as our reference book? Because it is very good. Okay, very easy to follow, and also the homework question. Not too hard, also not too easy. Then I tell you, very much with the real AP Phase 1 national test, very much. Okay, so that is we will use this reference book basically as the homework purpose. Okay, you can get any word of this book is okay. Okay, no big difference. Okay, so they are same for our purpose. We will use this book as our reference book. You do the homework, then you in this book they have a detailed solution for all the homework questions. Then that's easy for you to check you did right or wrong. But it's not enough. Why? You know you did wrong or correct, but I don't know. So what I will going to do? I will give everybody a quiz after every chapter. Basically, I will send you a quiz after each chapter. For example, after today, we will finish one chapter. Then tomorrow, you will get a quiz. Then remember, first do the homework. Okay, don't first do the quiz. Okay, always first finish the homework. I list the homework in the syllabus. First finish the homework, then check your solution, then do the quiz. I send it to you. Then submit me back. Then I can check your progress. We make this kind of procedure because our class is very fast pace. You know, if you learn the AP Phase 1 in your school, usually will take your the whole year. Most school, they take your whole year to learn the AP Phase 1. That means 30 weeks you learn AP Phase 1 from your school. But we only have 15 classes. That means we only have 30 hours. So we will use 1 hour to learn the things. Usually your school will take 1 week to learn. So you can say that's usually just very fast pace. So everybody should be work hard. Okay. Then again, after each lecture, try to work on the homework. Also try to finish the quiz I send it to you. Each of our class will be recorded. Okay. We said our class is very fast pace. So you may feel some part is harder, then you may always review the recording the video. Means that so you can always review the lecture by the videos. So the video will be available to you, available to everybody the next day. Okay, then today tomorrow that video will be available for everybody. Each class will be a 2-hour session, but in the middle we will have a 10 minutes break. So that means that 10 minutes break you can go to bathroom or drink some water. But I hope everybody during the lecture stay at your desk. Okay, so that is some simple introduction about our class. And then we start the lecture. Okay, so we said our class we call AP Physics 1. We try to learn physics. Then number 1, try to tell me what means physics. In your mind, I think you may have a different idea about what is physics, but I want to tell you, physics number one priority is to study motions. Okay, so we said when we try to talk about what means physics, physics is the science to study motions. Okay, that's the number one thing. Physics will do means study motions. Then how many different motion we have? In the daily life, you may see many different kind of motion, but in physics, we only have 3 kind of basic motions. That is what? That's a translation. We said in physics, we only have 3 kind of motion. We said that's a translation. Okay, this is a translation. Translations, rotations, and oscillations. Okay. In physics, we only have these 3 kind of motions. In the daily life, many complicated motion just try to combine these 3 basic motion together. Then you can get a very complicated motion in daily life. Then my second question is what means motion in physics? Okay, then we said physics is trying to study motion. Then we said what is means motion? What is means motion? So what is means motion? Motion is what? Motion is the changing of a position. Okay, motion is just the changing of positions. Means we said that is in physics. We give the definition. What is means motion? That is the changing of positions. Okay, somebody asked me a question. That's very good. Okay, changing. Somebody answered me a question. Okay, that's very good. Okay. Remember, everybody, we are always encourage you. Ask me any kind of question during the lecture. Also, we encourage you answer the question during the lecture. Okay, everybody, please try your best to be active in the class. Okay, so we said that motion is the changing of position. Then, if you want to study motion, do you know what you are going to do? We will introduce some basic quantities. So we will introduce some basic quantities. Then number one, we will introduce what is means position. Okay, what means position. Okay, this is number one. We will introduce what means positions. So we try to introduce position like this way. Number one, we need to have a reference. Okay, that is if you learn the coordinate geometry, then we said we try to have a reference. Okay, we try to have a reference. You say we try to have a reference. Then we try to have an origin. Means that we try to have an origin. Then if you want to tell somebody the position of your home, your home. Well, how can you tell somebody the position of your home? You tell somebody your home is here. Then your home is here. Then you need to tell somebody just your home is how far from the origin. Yes or not? This is how number one. You need to tell them a value how far. Okay, we said you need to tell somebody a value. This is how far. Means how far. How far? That's a value. Okay, that's a value. But anytime when we try to give a value, we need what? We need to have a unit. Okay. Anytime when we try to talk about a value, we need to have a unit. Then you may know, in daily life, we have many units about the length. This means how far. But in physics, we cannot do that. Okay. So you said the value, how far, the length. We have many units in daily life, but in physics, if you do like this way, that's a big method. So when we learn the physics, we will ask somebody follow a unit system. So we said this value need a unit. Then is unit. When we learn the physics, we need somebody follow the same unit. We call SI system. Okay, we call SI system. S is means system. Okay, S is means system. We follow the SI unit. S is means system. I is means international. Okay, international. So that is everybody. When we learn the physics, we use SI units. The SI unit, we have two categories to build up SI unit. So we say that that's SI unit. We have two categories. One category we call fundamental unit. Okay, fundamental units. So we said that is one category we call fundamental units. Then everybody know in physics we have hundreds of physics quantity. Means that somebody may have the feeling we have many fundamental units. Then I tell you no. In SI unit system, fundamental units only have 7. Okay, fundamental units only have 7. Means that we only have 7 fundamental units. For our AP Physics 1 class, we will know 4 of them. Okay, we only need 4 of the fundamental units. Okay, so that is we said we only have 7. Then right now we try to give the unit for the length, how far the length of value. Then we need a number. We need a first fundamental units. Then that is length. Okay, we said we only have 7. Right now we learn the first. That's the length. Okay, that's the length. Length in SI unit system. Then the length is in meter. Okay, is in meter. Length we said we use meter. Then we just simply write down. That's meter. We just simply write down. Is meter. All the fundamental units we need to give a standard. Remember, that's what we call fundamental unit. That means before you do anything, you have to make a definition, define some fundamental units. How we define them? We need a standard. What means standard? Like that, okay? Somebody somebody cut a piece of metal rod. Okay, we said somebody cut a piece of metal rod. Then we tell everybody that is 1 meter. 那个啥上了 that is how we define what is fundamental unit for meter. Somebody just cut a piece of metal rod. Then we tell everybody that is 1 meter. We save that piece of metal rod into the museum. That museum is in Paris. Okay, this museum is in Paris. Then we said tell everybody that is 1 meter. That's it. Okay. So we said we got the length meter. If you want to know your length, then go ahead, go to Paris to try to compare what is the standard metal rod there. Not really. Okay. We have a modern way. Okay. I tell you that's a traditional way. Okay. I tell you that's a traditional way. Just by the concepts. That is the way we define what is 1 meter. So we learned in the meter. So that is one category units. We said we know how far. So each time we finally know that your home is how far from the origin. That's the reference point we choose. Then we said, okay, we call this one, that's the length. Means that that's the length. That's the length That's the answer. But I tell you, that is not good enough. If you just tell everybody your home is 500 meters from the reference point, then you know what? All the location 英语是 circle, all the location 英语是 circle. They will have same distance. They will have same distance from the reference point origin. Isn't that? All is a circle. They have same distance with its reference point. Then that is not good enough to determine your home position. Then what we are going to do? We need to tell somebody the direction. So besides the value, we also need a direction. How can we tell somebody direction? We need a reference direction. Okay, for example, we said we have reference direction. We call it x-axis. We have its reference direction. We call it x-axis. Then if you try to tell somebody the position of your home, then we said you just tell somebody another quantity. We call the direction. We just use the angle. We said we can tell somebody the direction. So that is, we said when we try to tell somebody position, not only we need a value, but also we need what? We need a direction. We need a direction. Is direction, we can just use an angle. Then each time we tell somebody that is your home, we mark like this way. Means we said we mark as is arrow. Then that indicates that's a direction. So after you tell somebody the value, how far, and the direction, that's the angle with reference axis, then we can exactly locate it where is your home. In physics, we have many quantities. We need both value and the direction. Then each kind of quantity, we give a special name. We call what? Each kind of quantity, we need direction and also need a value. We give them a name. We call vectors. Makes sense? We call vectors. Before, when you learn the math, most of the time, math only need a value. If we only need a value, then that kind of quantity we call scalars. We call scalars. But if we need both the direction and the value, then we call vectors. How do we mark the vector about your home? Then we said we're using this one. We're using R. Okay, we're using R. That is a vector. Okay, we said a vector for the position. Many times we just using R. Okay, R. I make it a cap. That is indicate that is vector by handwriting. If it's print, we will use the bold letter. Okay, we use the bold letter. Then we mark it as a vector. But while handwriting, I cannot tell that's bold or normal. So I use this one. Makes sense? So that is, we said the positions, we just use R, make a cap. So that is we mean position. We are done for position. But we said motion is the changing of a position. How can we define what means changing of a position? We have two quantities. So we said the changing of a position, we need two quantities. Then 这是 two quantity. We call what? We have two way. One we call displacement. And distance. Okay, we have used two quantity to talk about the changing of position. Then what we have two quantity. One is we call displacement. One we call this displacement. Another we call is distance. Then what is the difference? Okay, that's number one. You need to understand what this displacement and the distance. What their difference is like that. Okay, so we said this is your home. Okay, this is your home. We said your home. Then your parents in the morning will drive you to the school. Will drive to your school. Then your school, we said, is here. Okay, we said your school is here. Then your school is here. Okay, that's your school. And each time we try to indicate the position of your home and your school. So we mark the position like this one. Okay, we said your home position. Your home position. Each time we mark as a position. That's a position. Okay, position of your home. Means this is your home. Then the position of your school, same thing. We need the angle, we need the direction, we need how far. That is your position of your school. I mark with school. Means I mark a school. Once again, that is also vector. That's also vector. Then you see what? That is position. Okay, that is position. But we said motion is the changing of positions. Then how do we count the changing? We have two ways. Number one, daily life. How we talk about the changing? Daily life is like that. Your parents drive the car. Okay, your parents drive the car. Your parents drive the car. So your parents drive the car along the road. But you know what? Road usually they have a curve. So your parents when drive you to school, they along the curved road. Then we said that is we call distance. Okay, that is we call distance. Remember, distance is means what? Distance is means the actual length what you passed. Okay, distance is just the length. Okay, just the length you passed. So is distance is a scalar. Okay, is distance is just the length you passed. That is a scalar. Okay, that's a scalar. That is daily life way. Usually we mean the motion, the changing of the position. But the physics don't do that. Physics do like that. Physics always draw a straight line from the very beginning to the very ending. Okay, so physics, when we talk about the changing of position, you just need to draw a piece of a straight line from the initial point to final. Then for drawing a straight line from the initial point to final, that is we call what? We call displacement. Okay, that is what we call displacement. Displacement we mark as delta r. Means that we mark as delta r. Delta is a Greek letter. In physics, that means changing. Means that in math also delta most of the time means changing. So you mark the delta r. This means changing of position. If you know the vector, if you learned the vector before, is changing of the position just equal to r final minus r initial. Means that. So that is what we call changing of position by displacement. Final position minus initial position. If you know the vector, then that's good. You can immediately understand what I'm talking here. But if you don't know the vector, read this book, okay? It's a prison review book. They have a special chapter talk about the vector. Means if you don't know the vector, remember, read that book. They have a special chapter just talk about is vector. So that is in physics we call displacement, changing of position. But the daily life we use a lot for the distance. Yes or no? For the distance. 这是 actual length. Is time. When we talk about the displacement and the distance, we don't need to introduce new unit anymore. Because 这是 length, okay? 这是 length outside. Then, but they are confusing. I give you an example. The test you everywhere, okay? In many scenarios, many tests, they will test you some question like that. If I have an object, the from here is initial. They moving in a half circle. They moving in a half circle. Move to a final position. Then it's a half circle with radius is, for example, with the radius is 10 meters. With the radius 10 meters. Then I want to ask you, what is the distance and what is displacement for this motion? Somebody already told me displacement. Okay, so what is the distance? Somebody immediately told me the displacement. Okay, displacement, we said, okay, displacement. Somebody know these things. Okay, displacement 这是 piece of straight line. 这是 from the very beginning point to the very ending. That we call displacement. Yes, displacement is just the diagonal, you can say. So each time you tell somebody this is displacement, it's just what? Somebody already told me. That is 20 meters. Not exactly correct. Because displacement is vector. You have to tell me what is the direction. Then you tell me to the right. That is the correct answer for displacement. Because displacement is vector to the right. Then what is the distance? Distance is actual length. That's D. D is a half circle. Half circle. That's what? Half circle. One circle is 2 pi r. Means 2 pi r. So that's a half circle. Then a half 2 pi r. Then I got 10 pi. I got roughly is 31.4 meter. Means so that is the distance. Okay. That is distance. Make sense now? Okay. That is, somebody asked me why is not to the right? Because I said that is initial, that is final. That is displacement always from initial point to final. If you know the vector, you will say final minus initial. That vector is from initial point to final. Okay. Okay. Then that is distance has no direction. Very good. Okay. One student told me distance have no direction. Then that's a question example. Then I ask you more. If that object keep moving, okay? If that object is keep moving, what means they keep moving? They move a full circle back. They make a full circle back. If that object moved one full circle, somebody already told me. What is the displacement? If for full circle, what is the displacement now? Displacement is always you join a piece of straight line from the very beginning to the very ending. But if you made a round trip, initial final position, that is the same. Then you have nowhere to join any line. They are same position. Then that means what? Displacement is 0. Okay, 0. That is make many students so confused. Okay, your parents cost that much gas drive you to school. Then in the afternoon, pick you up, back to home. Then you told your parents the displacement your parents did in his whole day is 0. Then your parents feel very unhappy. But that is physics. Okay? Physics, this displacement is 0. Then distance will be what? The whole circle effects. Okay, very good. We have students keep talking, tell me the answer. The distance, that's 2 pi r. means that circle effect 2 pi r. Then it's equal to what? 62.8 meter. Means that. So that is daily life. Your parents cost the gasoline traveled is distance. But in physics, we are more pay attention to the displacement. Okay, that is the difference for the displacement and distance. Make sense? Okay. So that is one simple example, but they like to test these things everywhere. Okay, so make sure you understand is a simple example. Then we said that is the motion, displacement, and the distance. Then next, what we are going to do, we always concern how fast is motion happen. It's not that we always concern how fast is motion happen. What means how fast? What means how fast? It means changing rate. Okay, that means changing rate. Then we talk about the next part. Next part, we said that you make the motion. That means changing of position happen. But we always concern how fast you make these things happen. Then that is means what? Changing rate with the time. So that is we always have two quantities. One is we call velocities. One we call velocity. Another we call what? And speed. Okay, and speed. Why we have two quantities? Because we have two quantities for the motion. One is displacement, another is distance. That's why we have how fast something happens. We also have two quantities. So we have these two quantities. We said velocity, we define velocity equal to what? Equal to displacement. Okay, remember that is displacement. Displacement divided by time. Means time is a scalar, no direction. Okay, time no direction. That's a scalar. So velocity is vector. Then speed is what? We define the speed is your distance divided by time interval. Because how fast, that means changing rate. Then each time, what we realize? We realize we need another fundamental unit. That is time. Means so we realize we need another fundamental unit. Another fundamental unit we need to introduce. This is time. In daily life, you can count the time in hours, minutes, days, years, but in physics, you can only count the time in what? Seconds. Okay, second. So that is SI unit. You can only count time by second. Second, simply write it down. That's the X. That's the X. Once again, that is the fundamental unit. What we are going to do, we need to give a standard. How to make a standard for the time? Your parents know by pendulum. Okay, by pendulum. Because your parents back to 40 years ago, we use the pendulum as the clock. That is how we traditional we define the time for 1 second. We set up a special pendulum. The pendulum make a back and forth round trip. That we call period. Then we just count how much time they make a round trip. We count that time interval as 1 second. Then we save to museum. That's it. But that is a traditional way. Okay, modern way we don't use that. Okay, but the traditional way can tell you how we define the fundamental units. Anyway, we have the fundamental unit for time. Then your velocity or speed, just the displacement divided by the time interval, or distance divided by the time interval. Then we don't need to introduce any new unit again. Then we don't need to introduce any new unit, fundamental unit. Then what kind of unit? What do we call? You say each unit, that's a meter. Top is meter. Then bottom is a seconds. Then that's the same. Means that the unit is meter per second. That kind of unit we call derived unit. Okay, so that is we call derived unit. Means that we have many hundreds derived units in physics. Okay. How can we derive the units? Now, by the formula, by the physics law, by the definitions. 明白是好的。So we have hundreds of derived units just by the formulas, definition, the physics law, any kind of that relation. They may give us some new derived units. So total together, we build up this SI units. 明白是好的。So that is we said that's SI units we use in physics. Then we get is derived units after we define the fundamental units for the length and the time. Make sense or not? But after we got velocity and speed, still not good enough. Still not good enough. Why is it still not good enough? Because if you pay attention to your parents driving the car, you will see sometimes velocity is bigger. They moving very fast. Then we said they have a big speed. Sometimes they moving slow. They have a small speed. So that means the velocity or the speed may be also changing with time. Then we need to introduce the last quantity. Last quantity we call what? We call acceleration. Okay, acceleration. What means acceleration? Acceleration is the changing rate of your velocity. Means that? So that is we call acceleration. Because ask your parents when your parents driving the car, sometimes moving slow, sometimes moving fast. Then that is means what? This means the velocity they will changing with time. Then we just find out the changing rate. Then that's what we call acceleration. Then each time is velocity is vector, acceleration is also vector. So that is vector. Then we call acceleration. Some students may be concerned. You say we have displacement and distance, so we introduce velocity and speed. But why you only introduce acceleration for changing rate of velocity? Why we only introduce acceleration for changing rate of velocity? Because meaningless. Okay. If you try to introduce changing rate is delta x is delta t, then I tell you this is meaningless. Okay, meaningless means back to 100 years ago, somebody really introduced is changing rate of speed, but finally we realized this is meaningless. Why is meaningless? 2 classes later, when we talk about Newton's law. Newton's law only related to the acceleration, no way related to this kind of quantity. So that why is meaningless. Means that, so we said that is meaningless, we don't care. Means that, so we only have acceleration, that's the changing rate for velocity. Once again, we introduce this acceleration, we don't need to define any fundamental units anymore. We just have derived units. What is the derived units? Derived units, your meter per seconds, you divide by seconds again, then you get a meter per second square. Means that is the derived units for acceleration. Then we are done. How to study motion. That's how to talk about motion, the changing of position. So if you try to tell somebody how we describe the motion, then we said we need to introduce 4 quantity. That is what? That is position, displacement, velocity, and acceleration. That is everything we need to introduce. Then we say, somebody asked me question, does acceleration work only for velocity? No, acceleration only work for velocity. We don't have similar definition for speed because it's meaningless. Make sense or not? That's a very good question. Okay, somebody asked me if the acceleration only work for velocity or also work for speed. The clear answer is acceleration only related to velocity. That's the changing rate of velocity, but not for speed. No similar quantity introduced for speed. No similar quantity like the changing rate of the speed. No such quantity. Make sense? No such quantity. We said, remember, okay, because 2 classes later, when we talk about Newton's law, you will understand only acceleration is meaningful for us. Okay, that's a very good question. Okay. So we said physics try to study motion. Motion is a changing of position. Then we said try to talk about motion. We need is 4 quantity. We put there. Also, we talk about unit system used in the physics. Then that's the basic definition for 1, 2, 3, 4 quantity. But that is not good enough. Because we said in my syllabus, I said physics is the science to study motion. if 有这是套什么的，在的意思 about motion， 真在的意思脑子的 sense。How to make a scientific way to study motion? We have to apply math, derive some formula to bound all its quantity together. Means so we have to apply our math knowledge to develop some formula to bound all its quantity together. Then make it scientific way. So that part topic in physics, we call what? We call kinematics. Okay, so that is our class 1. Then that is we call kinematics. Kinematics. Kinematics is just apply our math knowledge. We try to derive some formula to bound all its 4 quantity together. Then that is a topic we call kinematics. Then how can we do that? How can we do that? Okay, we try to say, we said, how can we do that? We said, okay, I remove these things. Okay, I remove these things. I hope you can get all the basic information done. We said we try to remove these things. We try to build up formulas. We bound them together. But before we bound the formulas, then we need to realize 环境. Okay, we need to realize 环境. What is the 环境 we need to realize? You see, we introduce velocity. Once again, we don't deal with the speed right now. Okay, speed is a daily life way. Okay, we want to work on the physics way. We said we introduce velocity. Displacement divided by time interval. Anybody when you learn the math, if you divided by time interval, that we call average quantity. Okay, this we call average quantity. Same here. When we talk about acceleration, your changing rate of velocity over the time, that is also averaged. Okay, it's also averaged. So we introduce this 2 quantity. You know what? They are averaged quantity. Okay, they are averaged quantity. But when we try to derive the formula, we don't like average quantity. Why we don't like average quantity? I show you an example. For example, if I give you a graph, this is position versus time. I give you a graph, position versus time. Then we set the position versus time. I have this fancy shape, position versus time. Then if we talk about the average quantity, for example, we try to figure out the speed here. We try to figure out the velocity here. We try to figure out the velocity here. Then, sorry, that's time. Okay, that's time. Okay, that's time. Then you try to figure out the average velocity by different time. Then you see what? If you choose the time here, if you choose the time here, if you choose the time here, if you choose is 3 different time interval, you choose is 3 time interval, you will see what? You will get a different average velocity. Yes, we said velocity is delta r over delta t. But if you choose different time interval, you see this interval here, time interval here. That is, if you choose 3 different time interval, okay, 这是有3 different time interval. Means 这是有3 different time interval. Then you apply its definition to calculate the average quantity, you will get a different value. Then in physics, we cannot allow it to happen. Because if you pick up a different time interval, you get a different value. How can we derive a formula, tell everybody that is velocity somewhere? We cannot do that. Then in physics, remember, in physics, in any kind of formula, we need what? We need instantaneous quantity. Means that we need instantaneous quantity. How can we make an average quantity go to instantaneous quantity? That is in the math, this limit concept. So instantaneous quantity, this instantaneous quantity will equal to what? You make the limit for the time interval approximate zero. That is, you pick up the time interval is super small. Then in the math, it means when delta t come to the limit 0, then each time your average quantity will back to instantaneous quantity. That is the same thing for here. We also need to get the instantaneous quantity. Then we said the instantaneous quantity drop the average. Then you need to take the limit. You make delta t approximate to 0. Then you make delta v over delta t. That is we have to do. Remember, in physics formula, almost everywhere in the physics formula only means instantaneous quantity. Means that unless some special case, they marked this average. Later, when we learn the related topic, like the work energy impulse momentum theorem, I may remind you again, somewhere we will mark as average. If they don't special mark as average, everywhere it means instantaneous quantity. Because only instantaneous quantity is unique for that moment. How about in the graph? What means instantaneous quantity? In the graph, instantaneous quantity, anybody know? This is tangent line, okay? That is instantaneous quantity. Makes sense? So instantaneous quantity on the graph just means make a tangent line. Tangent line at any special point is unique. Yes or not? At any special point, moment, the tangent line is unique. Not like average quantity. You pick up different time interval, you get a different value. But instantaneous quantity corresponding to the tangent line to its point, that is unique. That is we have to use in all our physics formula. Then we will see how we derive that formula. So after we finish all is averaged to instantaneous, then we said how we derive the formula. Then we said not that easy. In AP Physics 1, if you want to derive that formula, the only thing you can do is constant acceleration. Means that, so AP Physics 1, all we can do is constant acceleration. That is AP Physics 1, we will special deal with constant acceleration. But remember, acceleration is a vector. We said acceleration is a vector. Your constant acceleration means 2g. Number 1, constant direction. Constant direction. Number 2, constant value. Yes or not? We said that constant acceleration, that's a vector. You have to have a constant direction. Very nice. If we have a constant direction, then what we can do? We take this direction. We take this direction as x. Can we do that? You see, in the math, when you build up a coordinate system, the x direction, you can choose any direction as x. Do you know that? You see, this x direction not necessary to must be horizontal. You can take any direction as x. But right now, I have a constant acceleration. Then that means my acceleration have a constant direction. I just take that direction as x. Perfect. Then if you take that direction as x, what's the benefit for us? What's the benefit for us? We may treat vectors as scalar. Yes or not? We may treat vectors as scalar. Because if you just have x, that's one component. For any kind of vector, if you just have x components, then that you can treat as scalars. Then that is super nice for us. Because I mark the position kappa, displacement kappa, velocity kappa, acceleration kappa. So noisy. Then finally, we make this one change to x, delta x. We dropped all the vector nature. Super nice. Yes or not? Otherwise, we carried that vector nature. That's really killing us. Vector calculation is so noisy. But I take that direction as x, all the vector nature gone. We just come to components behave like scalars. So that is why it's a benefit for us. Constant direction. Then take 10 minutes break before we talk about what's the benefit for constant value. Like we mentioned, we back 8 to 10. So we take a 10 minutes break to drink some water or go to the bathroom. Okay, I will see you back in 10 minutes. Okay. Okay, it's 8:10. We start. Okay, so we said we talk about what is the benefit from the constant acceleration. How about the benefit from constant value? Then I told you, hope you agree. Constant value make us instantaneous acceleration will equal to average acceleration. Do you agree? If acceleration is a constant value, who cares if it's instantaneous or average? They are same, is it not? And then they are same. We said instantaneous will equal to average. But average we know. Average we know this is delta V over delta T. Is it not? What means delta V? V final minus V initial. Then what is delta T? T final minus T initial. Make sense? Then we don't call V initial as V initial. We call V initial as V naught. We call V final as V. We can do that. That's our choice. We give them name. We call V final equal to is V. We call V initial is V naught. That's our choice. We have the power. We can do that. Then what is the T initial? T initial, we take them 0. Why? We start counting the time as initial. We can do that, is that? We start counting the time as a T initial moment. We can choose is equal to 0. Then we call T final as a T. Then we got what? We got V equal to V naught plus over T. Is that? We ignore old in the middle. Then we just get A equal to V minus V naught divided by T. Make sense? That is the formula. If you are in the hacker just give students formula sheet like this way. Okay, hacker give students formula sheet like this way. But I don't like this way. Also, that is not college board way. College board will multiply T both sides. They multiply T both sides. They got AT equal to V minus V naught. They got what? They got V equal to V naught plus AT. Make sense? V equal to V naught plus AT. That is our first formula. V equal to V naught plus AT. Make sense? Once again, Hacker gave the formula sheet like this way. I like this way. Also, college board using this way. Make sense? That is our first formula. How about the second? Second, we got trouble. Second, we try to use V average. We said we try to figure out the displacements. We said V average equal to delta X over delta T. We try to use this one. But right now, my V is not constant anymore. Because you see, my V is changing with the time. My V is changing with the time. It's not constant anymore. Then, how can I find out the displacement? In the syllabus, I give you arguments. What is the arguments I give you? I give you, if you try to change the V average, change to V instantaneous. If you try to use the V instantaneous velocity, replace the average velocity. The arguments I give you, delta X is the area under the graph of V versus T. Means in the syllabus, I said if you want to use instantaneous quantity V, replace the average velocity V average, then delta X is the area under the graph of V versus T. That arguments, don't worry about now. That is basically, that's the definition for integral. Someday you learn the calculus, you know the integral. That is the basic definition. What means integral? But right now, we just take this one as correct. But how we find out the area under the graph? Then we join that graph. Means we join that graph V versus T. Means V versus T, V equal to V naught plus AT. If anybody learned the coordinate geometry, V equal to V naught plus AT. It's like that, straight line, isn't that? V equal to V naught plus AT. That's a piece of straight line. Then is y-intercept is V naught. Means this y-intercept is V naught. Then your delta x is the area under the graph. Then what's the area? That is the area. Means so we said that is the area. We mark that the area is like that. Means we mark the area like that. Then is part is what? Is what? Is point is V. Is not? Is point is V. That is value is V. That value is V naught. Means you see, is one is V naught. Y-intercept. That is V. Then that is T. Okay, that is at time T. Time T. Then we said delta x is the area under the graph. Then that is area under the graph. We said delta x equal to area under the graph. That area is what? Trapezoid, yes or not? That piece of area is the area for the trapezoid. Trapezoid, everybody know the formula or not? The formula is base 1 plus base 2 divided by 2 multiple height. Means multiple height. That is the area. That is area under that graph. Means somebody know that. Okay. Somebody know that. Okay. So we said somebody know that. We got this one. That is our second formula. Means so that is our second formula. Delta x equal to V naught plus V divided by 2 multiple times. Means so we just get our second formula given by this one. Means so not that. So that is our second formula. Okay, we are done. Just by its arguments, we are done. Make sense or not? So we got our two formula. We got our two formula. I tell you, in principle, that's good enough. But if we want to try to solve the problem quickly, that is not good enough. We will derive more formula. Okay, we will derive more formula. How to derive more formula? I substitute this V equal to V naught plus AT to here. Oh, just give me 1 minute. Okay, I have something turn on here. Okay, so we set up. Okay. Okay, everybody. Okay, so we said we just substitute this one to here. Means we substitute this one to here. Then we got what? We got is V naught plus V. V is V naught plus AT. Then divided by 2 times T. Then we simplify. V naught plus V naught, I got 2V naught plus divided by 2. Then I got is V naught T. Then plus half AT squared plus a half AT squared. Then we got our third formula. Third formula is just delta x equal to V naught T plus a half AT squared. You see, very quickly, we already derived 1, 2, 3 formula. Then I will say still not good enough. Why is still not good enough? O is 3 formula. They have what? O is 3 formula. They have the time t. Do you realize or not? O is 3 formula. They have time t. We try to get 1 more formula without time t. Okay, we try to get 1 more formula without time t. How can we do that? How can we do that? Okay. I remove some things we don't need. Okay, I remove something we don't need. I remove something we don't need. We said we got this one. We got this one. I remove something we don't need. We said how we got the last formula. Last formula. We try to get rid of t. Then from here, I got what? I got v minus v naught equal to at. Then I got what? I got t equal to v minus v naught divided by a. Means we said I got t equal to v minus v naught divided by a. Why we do that? We just get 1 more formula without time t because we want to have a different formula to help us solve the problem quickly. So I get rid of t. Then after I make the t, I substitute the t here. I substitute here. Then I also substitute t to here. I make this substitution. Then we got what? We got delta x will equal to v naught times t, v minus v naught divided by a. Then plus a half a t square. T square. Anybody know how to calculate t square? T square, I got a square here. V minus v naught square. V minus v naught square, I got v square minus 2v naught plus v naught square. Yes or not? I substitute t to here. I take the square. I got a square v minus v naught square. This is the formula. I got that. Then we make a little bit of simplification. Simplification, I cancel out is a with is square things. We still don't like. I cancel out this one. I still don't like. Why? I don't like they have denominator like this one. I don't want they have a denominator. So I multiply this side and that side with 2a. Okay, because I try to cancel out all of the denominator. Then I will also multiply this 2a. So I multiply 2a both sides. We try to get rid of denominator. Then what I got? I got 2a delta x. I multiply 2a. Cancel this a. Cancel this a. I got 2v naught v minus 2v naught square. Yes or not? I got 2v naught v minus 2v naught square. Then I just plus v square minus 2v naught plus v naught square. Means that then we keep simplify. I make this one cancel out with this one. Cancel out this one. Then we combine this one with this one. With what? With minus v naught. With minus v naught. Square. Sorry, that's a v naught square. Then I have v square here. But I don't like a negative v naught square here. I move this one to another side. I move this one to another side. If we move this one to another side, it's changed to positive. It's not we make this one to another side. we change to positive. We change to positive, then we got our last formula is v square equal to v naught square plus 2a delta x. Yes or not? I move this one to here, change to positive, we got our last formula. Then I told you, is 1, 2, 3, 4 formula. That is everything in kinematics. No more, no less. Just is 4 formula. Why I said that's no more? Why I said it's no more? Because police review book, they use 5 formula. They call big 5. Where is big 5? They have another formula. Okay, they have another formula. Police review book, what they call big 5? They have another formula. It's from here. That is delta x equal to vt minus a half at square. That is what is the Princeton review book use. Big 5. I don't recommend you remember that formula. Why? That is very easy to mix up with our formula 3. Very easy to mix up. You see, we start from v naught, they start from v. V positive plus a half at square, they minus a half at square. Then I tell you, for the beginner, that's very easy to mix up this formula with that one. That's why I don't recommend you do that. Make sense or not? Because in most scenario, they will give you the initial velocity. So this formula is more useful than another one. Then I don't want to remember an extra one. Try to mix up with this one. I don't want to do that. If someday you need that formula, you're very easy to do that. Okay, before we substitute v to here, then we got the formula. Means we substitute this v to here, we got this formula. Next time, if they need this formula, you just substitute v naught. You substitute v naught here, because v naught equal to v minus at. Okay, you substitute v naught here, that's equal to v minus at. You immediately got that formula. If someday you really need to use that, like the Olympiad physics competition, some very few cases, you may use that. Then you just easily to derive, make a v equal v naught equal to v minus at, substitute this formula. So I don't want you remember that formula now to bother you. That's why I said no more. Why is I also said no less? Because college board formula sheet don't have the second formula. Because someday, if you take the AP Physics 1 national test, they don't have the second formula in the formula sheet. But I tell you, second formula is super important in some cases. Besides, you know, in our logic, we derive the formula. We first get that formula by the area of trapezoid. Then we substitute, we got the third formula. That's our logic. If you don't know, we have that formula first. Many students asked me before, why we have the half there? Okay, that's many students asked me before. Because their school don't talk about the second formula. They just give them the third formula. They don't know where is half come from. Okay? They don't know where is half come from. I told them this half come from the trapezoid formula. Then they fully understand. So that is by our logic, we need a second formula. Also, I tell you, second formula is very important for some cases. That's very convenient for us to apply. So I recommend you remember the second formula. Then no more, no less. Also, I want to use remember is a full formula exactly like the format I present here. College board not do this way. College board, they don't use delta x. They said they use delta x equal to S final minus S initial. They don't do that. Okay. S final they call x. S initial they call S naught. So college board don't use delta x. They use x minus S naught everywhere. I don't like. Why? We want to use remember is a full formula. Also, we want to use remember is a full formula for a long time. You know, right now, AP Physics 1, AP test don't need you remember any formula. But if you want to take an Olympiad physics competition or physics ball competition, you have to remember that formula. That is AP Physics 1 for constant acceleration. Someday you learn the AP Physics C. They don't need a constant acceleration. But is a full formula still heavily tested in AP Physics C. Means that AP Physics C not necessary only for constant acceleration. But that is still the most popular case they will test you in AP Physics C. Someday you go to the college, they still test you is a full formula. Someday you want to go to medical school, you need to take MCAT exam. MCAT exam for medical school don't test your math anymore, but they still test your physics. They still heavily test is a full formula because I helped many students to prepare MCAT for their medical school. This is a full formula. It's still heavily tested. If you want to go to graduate school, you need to take a GRE in physics. That is a full formula. They still test you a lot. So basically, you need to remember it's a full formula for the all your high school, college, graduate school, medical school. Why not remember them now? If you want to remember them in a long time, you have to remember them in the simplest format. That's why I don't recommend use the college board. Means that college board use the S minus S naught everywhere. Even you make a formula a little bit complicated, that will bother you. Remember them for a long time. Plus, in most question, they ask you the information about the displacement. Okay, remember delta x is the displacement. You write it down x minus S naught. That is position. X and S naught. That's final position and initial position. But I tell you, most of the time, they will ask you, they will test you for displacement, delta x together. So that is what I try to convince you. No more, no less. Also, remember the exact format. That is also the reason why I derived this full formula with you together. You saw that this one just from the constant value of acceleration. This one we said this is area for that trapezoid. Then you substitute here, you get this one. You remove the time, you get that one. That's the logic. We derive this full formula. That's also help you remember them. You don't need to derive them during the test moment, okay? But that's help you remember them. So after we have this full formula, we said that's everything in kinematics. Then what we are going to do? We need to practice how to apply this full formula. Help us solve the problem quickly. Then we make one example how to apply them. Okay. That example, I said your parents try to drive the car. Then start car, they push the gas pedal. They push the gasoline pedal. Gas pedal. They push the gas pedal. Then they got the acceleration. Okay, they got the acceleration. They got the acceleration. So in the syllabus, okay, in the syllabus, I put that example in an easy way. Then we said they start the car. Okay, start the car. Okay, start the car. This means what? Ha, your parents start car. This means v naught equal to 0. Yes or no? You start the car. Your initial velocity equal to 0. Your parents push the gas pedal because you are too young. You are not legal to drive the car. So have your parents do that. Then give your acceleration is what? Is 5 meters per second square. Then for how much time? T equal to 4 seconds. T equal to 4 seconds. Then I want to ask you, what is the, under that condition, what's the speed or velocity they achieve? Then what is the displacement? Your parents' car move. Then after we know this initial information and other additional information, how to figure out the V? We just pick up the correct formula. Then figure out the V is no any other choice. Then basically only choice. This is straightforward. I pick up the formula for the one. We said V equal to V naught plus AT. Means plus AT. Then you just plug in the value. We said V naught equal to 0 because start from the car. Then your A is 5. Then multiple time is 4. Then equal to 20 meters per second. Make sense? Then I want you to pay attention. When I do the calculation, I ignore unit in the middle. Do you pay attention? When I try to do the calculation, I ignore the unit in the middle. That is what I recommend. But if you are in Hacker, then Hacker physics teacher always asks students put unit everywhere. Okay, Hacker physics teacher always asks students put unit in the middle of calculation. I don't like. Why? Take you too much time. Especially someday when you take the real test, like the Olympic physics competition, that time is very urgent. Even you waste a little bit of time when you try to write down the unit, then that is make you in a bad situation to finish the test on time. Means that also, if you already have that habit, carry the unit everywhere, someday when you go to the real test, you try to change the habit, ignore the unit, believe me, you will feel not confident. So that is what I always recommend students. Ignore the unit in the middle, but you have to give correct unit in the end. Then I tell you, this way they will always give you full credit by College Board. Only make sure everywhere have to be in SI unit. Okay, we can do this way under the condition everywhere you have to apply SI unit. That is the very reason why in physics we ask everybody follow the SI unit, because you don't need put the unit everywhere. Then save you a lot of time, believe me, save you a lot of time, especially for some very complicated scenario. Means that, then we got this one. How can we get the delta x? Anybody know how to get the delta x? Then I tell you, after we got V, you pick up 2, pick up 3, pick up 4, pick up everything, you get the delta x. Okay. After we got V, you pick up 2, 3, 4, everything, you can get the x. Then one student tell me pick up 2. I'm fully understand. Why you want to pick up 2? Because easy. Because that's a linear calculation. This is easy. But I still recommend calculate the x using v naught t plus a half at squared. One student tell me use the 2. No problem. You do the linear calculation, you feel easy. Why I recommend 3? Because you don't need to worry about carry mistake. Especially someday you take an Olympic physics competition or physics ball competition, they are multi-choice question. They don't give you any credit for your procedure. Just judge your final answer is correct or not. In that case, if you made wrong on the way, if you apply second formula, you will carry that mistake to the x2. Anybody see that or not? The student tell me pick up number 2. No problem, correct. But what I'm worried about, you will make carry mistake if you made wrong when you try to get the way. If you made wrong on way, you put there, you will get third x wrong. Then if it's multi-choice, that's 0 credit for any kind of carry mistake. For multi-choice, that's 0 credit. So I will recommend students always try to apply the information they gave you in the beginning. So that's why I recommend that formula. Then you plug in v naught equal to 0 plus a half a is 5, t squared is 4 squared. Means t squared is 4 squared. Then you get is 1 equal to what? 40 meter. Means remember, you need to do a lot of practice. Then you can get the feeling which formula is best to help you solve the problem. Then we said I recommend is 2 formula. So that's question 1. Then question 2. Then right now your car is moving. Okay, your car is moving. Okay, your car is moving. At what? At v. At your car is moving at 20 meters per second. Then your parents see the traffic light turn to the right. See the traffic light turn to the right. Then your parents try to brake. Push the brake. Push the brake. They got negative acceleration. That's de-accelerator. Then negative acceleration minus 10 meters per second square. Have anybody pay attention when your parents see the traffic light turn to the right, they push the brake? What they are going to do? They are going to watch the time, count 1 second, 2 seconds, 3 seconds, 跨式的。Have your parents do that? Watch the time when they push the brake? No, nobody do that. They will make the car crash happen. So when they push the brake, only thing what they concern that is delta x to stop. Means they always pay attention to the displacement. Try to make the car stop. No anybody push the brake. They count the time 1 second, 2 seconds. Nobody do that. Then, if I ask you the displacement to stop, then which formula are you going to pick up? Which formula are you going to pick up? Then we said 1, 2, 3, 4 formula. Only last formula, we don't have time because nobody watching the time when they push the brake. So only the last formula without the time. Then we use the last formula, v square equal to v 0的square plus 2a delta x。那个啥 ，I plug in the value. What's the value? v square 你 stop 的 equal to 0， 你想啦 v square 你 stop 的，你看我这 r0 delta x to stop。在 v initial 我看 v initial 这 set right now 这样 moving with 20 square， 为啥？这样 moving under 20， 为啥？在 plus 2a。A is what? Remember, this is negative time. Then you make delta x. Then you can calculate what's the delta x. Delta x will equal to what? Delta x equal to 20 meter to stop. Means so delta x equal to 20 meter to stop. That is why the very reason why we derived full formula. Just try to make you have the choice to pick up the best formula to help you solve the problem. Means that, but you need to do some practice after the class. Then you try to figure out at what kind of situation you can pick up which formula to help you solve the problem best. Okay, that is the example. How to apply that full formula. But we will give you a lot of homework. Also, I will give you a quiz. Yes or no? I said after you finish the homework, don't forget to do the quiz. Okay, then you need to send the quiz. You are encouraged. Okay, no any mandatory here. Okay, this is some. No any mandatory there, but you are encouraged. Finish the homework first, then finish the quiz I send to you, then submit your quiz back to me, then I can check your answer. But anyway, I will publish the answer after the next class. Make sense? Okay, so we said you need to do a lot of practice, try to figure out, get a feeling how you pick up the correct formula to help you solve the problem quickly. Then we talk about the last things, graphing. Physics, we do a lot of graphing things. Okay, we said physics, we do a lot of graphing. So what kind of graphing we have? We do the graphing, we do three kind of graphing. Okay, we do three kind of graphing. One graphing is the position versus time. Another is velocity versus time. This is versus time. Then another graphing is the acceleration versus time. Okay, we do this three kind of graphing. Okay, physics, we said we do a lot of graphing. Then we talk about the easiest case, x. Position, remember x is position, okay? We said x is position. Then delta x is displacement. But when we do the graphing, we make a simplify. We make s naught equal to 0. Can we do that or not? I choose the initial position as our reference point, our origin. We can do that or not? We choose the initial point as our origin. We can do that. Okay. Then I just get delta x equal to x. Okay. I make delta x equal to x. Then x. Then we said x versus t. Okay, x versus t. I got this one. Then this time, I tell you what, x versus t. Like that. Huh? What does that mean? This is position. This is time. Position, time. That means at a different time, my position always same value. Then I want to ask you, what is the v versus t? What is the a versus t? Anybody can give me a answer. What is the graph v versus t? Acceleration versus t will be look like? 谁的啦？有他们谁的啦？ But Switzerland too many. Okay, too many way. Okay, but you answer me immediately. Okay, you answer me immediately. Okay, okay. Switzerland we have too many. Okay, but your position doesn't change with time. So that means you doesn't move. Okay, you doesn't move. You doesn't move. If your velocity always zero of case, your acceleration equal to zero. Okay, of your acceleration equal to zero. Makes sense? So some students already told me. Okay, already told me. That's always equal to zero. Your position is steady forever. You steady forever. This means you never change it. Okay, you never change. Okay. 这是 case 1。case 2 is like that. Case 2. If I give you v, what is t? I give you v, what is t? 这是 my velocity. Like that. What does that mean? That means my velocity at different time, they always maintain constant value. 这是what they try to tell us. Is not my velocity at a different time moment, then they maintain a constant value. Then what I want you to figure out? I want you to figure out what is acceleration, what is time t, what is the position, what is time t. Anybody can give me information about acceleration versus t? Somebody already. So many tell me. Okay. My velocity is always constant. That means it doesn't change. My acceleration is zero. Then my position versus t. Somebody also tell me straight line. But is straight line is what? Is straight line. Okay. Somebody already told me. Okay. Is straight line. Is straight line. Like that. Yes or no? Is straight line like that. Why? V always equal to V naught. Okay. V always equal to V naught. Why is like that? Why is like that? I told you. Use the formula. Okay. Use the formula. Use the formula. We said delta x equal to x right now. Okay. Delta x equal to x right now. Delta x equal to x now. Okay. Delta x equal to x now. Delta x equal to x now. Then x equal to v naught t plus a half a t square. Then your a equal to 0. You tell me a equal to 0. Then you get v naught t. x equal to v naught t. That's a piece of straight line like that. Makes sense? X equal to v naught t. This is a piece of straight line like that. Makes sense? Okay. No big deal. Then we talk about the next one. If I have a versus t. If I have a versus t, like what? A versus t, like this one. Like this one. Then what I want to figure out, I want to figure out v versus t. I want to figure out x versus t. Anybody have the idea? I have a versus time. That means at a different time moment, my acceleration always have the same value. That I always have the same value, and that means constant acceleration. Constant acceleration. What is my way? We take a simplified case. Okay, we take a simplified case. We take a simplified case. We take a v naught equal to 0. Okay, we take a v naught equal to 0. Then we set what? We set v will equal to v naught plus at. That's a constant acceleration. Then we set S1 equal to 0, just equal to at. At equal to what? At straight line. Like that. Is that? Like that. Means that's v versus t. Because my acceleration at a different time moment always have a constant value. My acceleration at a different time moment always have constant value, then like that. 明啥？那个意思。Then how about my position versus t? How about my position versus t? Somebody already told me 这是 problem。OK， 这是 problem， 意思呢？这是 problem。somebody told me is potential. Is potential. We don't call is potential because each time we are still using that formula. We using that formula. We said x. I said delta x change to x. Okay? Delta x change to x. X equal to v naught equal to 0. Then a half at squared. Means because x equal to v naught t, my v naught equal to 0. My v naught equal to 0, so I got a half at squared. X equal to a half at squared. That is what? Facing up problem. Okay? Facing up problem. That is what is shape. Means if you learn the math, this one is facing up problem because that's a positive acceleration. Means it's positive acceleration. That's a facing up problem. But we don't call is potential. Means somebody answer me, this is potential. We don't call is potential because that's a quadratic. That's quadratic. Means quadratic equation. This is problem shape. So that is a basic graphing. Means when you try to figure out basic graphing, then basically from the equation, that's the best way. Okay, from the equation, that's the best way. Then I tell you, if purely based on the graphing, like that, okay. If I have the xt, this is position versus time. You try to figure out v versus t, this is velocity versus t. But that relation, we said v is equal to delta x delta t. Is v equal to delta x delta t. Delta x delta t, remember, this is slope. Okay, this is slope. Means if you from the v versus t, you try to figure out a versus t, acceleration versus t. Then you also remember this a equal to delta v over delta t. A equal to delta v over delta t. Then that is also slope. Means this is also slope. Means you say from this direction, I got a slope. From that direction, I got a slope. If you want to make it bounce back, anybody know if you back, what's happen? That is opposite operation in math. Slope, current pumping, area. Some tell me anti-derivative. Anti-derivative, this is calculus. Okay, this is calculus. That is we call by area. Okay, by area. Somebody tell me anti-derivative. That is perfect correct. Okay, this is perfect correct. But the AP Physics 1 is algebra based. So we said this is by area. Okay, so by area means slope. That's the students already know. That's a derivative. Then your backward, we call anti-derivative. Anti-derivative, that means by area. Okay, this means by area. Means so remember, this direction, I got a position versus time to velocity versus time, slope. From here, get acceleration, slope. But you make a back by area. You count the area under the graph. Means but you see what your velocity always located in the middle. Okay, your velocity always located in the middle because from the velocity you can get a position versus time and from velocity you can get acceleration was time. Then we give you a more complicated example. So after we know all is the basic information, we together we work on a complicated example. Complicated example is like that. We said we need to make the velocity in the middle. We say we need a velocity in the middle. So velocity in the middle. Velocity in the middle. So I give you velocity. I give you velocity. I give you velocity versus time. Versus time. Then velocity versus time. Like this one. Like this one. Okay. Then I want you to figure out what is the acceleration versus time. I want you to figure out what is the position versus time. Make sense? So I give you velocity versus time like this way. Then you need to pay attention to the special moment. Okay, you need to pay attention to the special moment. Okay, we'll do that. Then you need to pay attention on the special moment. Make sense? Then you will say, you will pay the special. Like that. Make sense? Then first, try to figure out the acceleration versus time. We know the velocity versus time. Velocity versus time. We try to get the acceleration versus time. Somebody give me, very good. Okay, give me a long answer. Okay, long answer. We said we make a position. We know the velocity versus time. We try to get the acceleration. We need to take a slope. Anybody know that one piece of straight line only have one slope? 这是yes or not? We said from V try to figure out A, you take a slope. Everybody agree. One piece straight line, we only have one slope. Then acceleration, try to find the slope. Is the slope, everybody agree, that's a positive. You saw that? That's a positive slope. Make sense? From here to here, everybody agree, negative slope. Make sense? That's a negative slope. You saw that? Because its slope is constant. Because for one piece of straight line, we only have one slope. So that piece straight line, I have a positive slope. That piece straight line, I have that slope. Okay, no problem. How about the position? Position is the same thing. Position, we said position, try to get away. Position, try to from the way. I need by area. From V versus T, try to figure out the position versus T. I need to count by area. Then I tell you, when you try to count the area, very hard. And when you count the area, very hard. Just always write for the formula. Okay, just write for the formula. We said that this constant acceleration. From here, constant acceleration. You just apply the formula. Is x equal to v naught t plus a half a t squared. I just use that. Then my v naught equal to 0. Then its position, I have a constant acceleration, t squared. 这是what? Problem. Facing up problem. Important common mistake is from here to here. Anybody have an idea? From here to here, what's happened? Its position is going up, or they come back. That is the most common mistake. Somebody give me correct answer. 2 students give me correct answer. That is still going up. Why? because my velocity from here to here, my velocity from here to here is still positive because it's above the axis. From here to here, my velocity is still positive. So they still keep moving forward. Because my velocity is positive, still keep moving forward. By its formula, that's a problem. Concave down. Excellent. Why is it concave down? Because you say my acceleration is negative. My acceleration is negative. My acceleration is negative. Some student already told me that's a concave down. Then the light is way. 意思到的 because 有 leading coefficient when change to negative, that's concave down. Then from here to here, my velocity already changed to negative. From here to here, my velocity changed to negative. This means my object moving back. My object moving back. Then some students already gave me answer. Like this one. Then I also want to tell you, this one will be in a perfect straight line. Anybody know that? Agree or not? Anybody agree? This point in perfect straight line. Why is perfect horizontal straight line? Because this part is a positive area. I have perfect symmetry. Okay, I have perfect symmetry. 没有一个在这里 cancel 好的 negative area. Okay, 没有一个在这里 cancel 好的 with negative area. So I will make this point and that point. 这样一个在这里 at the same position, same location. Because after they pass here, we said that's the area about the displacement. This piece area is positive. Okay, this piece area is positive. But when they move from here to here, that piece area is negative. I assume they have perfect symmetry. Even my drawing not that good. But if they have perfect symmetry, this piece of positive area will be exactly cancelled out by this piece negative area. So your positive A cancel out with negative area. Then you make a total area equal to 0. You make total area equal to 0. That means you make 0 displacement. Count together. You count together, you make 0 displacement. Then that means y make this position and that position. Then they are same location. Means if you feel it's hard, then try to think about after class. Means I said here they are same location because positive area and negative area they cancel out. Then they are same location. Okay, how much you understand all these things? Once again, I want to tell you again, our class is fast, very fast paced. Okay, your school take 1 year, 30 weeks. We only have 30 hours, so that's a very fast paced. If some part you feel hard, perfect normal. Means that if some part you feel hard, perfect normal. We have video available to you. If you still feel hard, you can review our video. Then after the class, what you are going to do? First, finish the homework because they have a detailed solution. Then I will send you a quiz. Then quiz, no solution there. Then try to finish the quiz, submit to me. Okay, this is encouraged. Okay, I mean again, this is encouraged. You finish the quiz, finish the homework. First finish the homework, check the solution. then you make sure you fully understand knowledge. Then do my quiz, submit back to me. Then I can check how much you understand. 明个啥知道的？这是 encouraged 的 ，OK， 这是encouraged 的。明个啥？哦 ，should you send homework to you？ 啊 ，of course send to me。再一个就是有homework，OK，I said OK，homework encouraged 的。明个啥 ？But homework they have a detailed solution in the book，so that's encouraged 的。quiz you have to send me because no solution there。明个啥 ？But I will publish the solution after the next class。明个啥 ？I give you the quiz tomorrow。Then after the next class, suppose you submit back to me. Then I publish my answer key, publish the answer key to everybody. So then you can check how many you get correct on the quiz. Means how many you get. First quiz I put 14 questions there. Okay, next quiz will have more than 20 multi-choice. Okay, 这是 all the multi-choice. Okay, I will tell you how can you submit. Okay, how can you submit? Submit homework to me. 这是 by email. Quiz I try to apply Google Classroom. Okay, I try to apply Google Classroom. So quiz if by Google Classroom, 这是 more easy for you to submit. 明白？ But homework you submit to me. 这是 only by email， 明白？ But that is 其实 encouraged， OK？ Because homework they have a detailed solution here， 明白？quiz I want to check how much you already get the knowledge， 明白啥是呢的 ？Okay, everybody, that is our first class. Hope everybody enjoy the class， 明白？So I wish everybody may work hard. Then I see everybody again on Wednesday. Okay, good. Have a good night, everybody. Okay, good night, everybody. Okay,
Thank you.
Good night.
Thank you. That's all.
Thank you.
Oh, you're welcome. Okay, you're welcome.
谢谢杨老师。
you're welcome. Okay, bye bye.